You are welcome to AG 304, Statistics and Field Experimentation. Study Section 4, the measures of central tendency. Mode. Introduction. In the previous study sections, you have learned how to measure central tendency of mean and median as peculiar to grouped and ungrouped data. Now in this study section, the measure of tendency to be considered here is the mode specifically. And mode is the observation which repeated itself in a set of data. In this study section, you'll be introduced to the mode as a means of central tendency and the relationship between the different measures of central tendency, that is the mean, median, and the mode. And hence, understanding the whole of this study session is very important because it is highly applicable in any statistical analysis, particularly in descriptive statistics. The learning outcome. At the end of this study section, you should know how mode is being calculated. 2. You should be able to explain the relationship between mean, median, and mode. Now, let's look at what we have on the board. Mode. The mode of a set of data is the observation which occurs most frequently. That is the observation that repeats itself most. Now, in some set of data, the mode may not exist, and if it does, then there may be two or more modes. That is, there may be two or more observations appearing, repeating themselves equally. Using this data that consists of 20 observations, just like we have on the board, then the mode of this distribution is 24, simply because it is only the 24 that appears most. Now, but if we have 1, 2, 3 or more modes in a particular distribution, then it is called unimodal, bimodal, trimodal, or multimodal, respectively, and as the case may be. Calculation of mode for grouped data. Now, the modal class is the class with the highest frequency. The mode can be estimated using two methods. One, that is drawing a frequency polygon and locating the value at the highest point. And the second method, which can be used to obtain the mode, is the use of the formula. Now, using this formula, that is L1, that is mode is equals to L1 plus F1 minus F2 all over 2F1 all over F0 minus F2 times C. Now, where L1 is the lower class boundary of the modal class, F0 is the frequency of the interval just before the modal class, and F1 is the frequency of the modal class. F2 is the frequency of the class just after the modal class, and the C is known as the class width. Determination of mode using a frequency curve. It is similar to what I explained in the previous study section. Now, with what we have here now, we have the class boundary along the x-axis, and we have the frequency along the y-axis. Now, we map the frequency with the class boundary, just like we have here. So we locate the point, we locate the point, we locate the point, then we join the points together. Now, with this, we can obtain our mode as the one that has the highest, that appears at the highest point of, of the frequency distribution. Now, determination of mode using formula. Now, considering this table that we have on the board, you can easily substitute, the values for the formula as we are given. As we are given here. Now, with what you have on the board, the modal class here is this class, simply because that is where we have the highest, mode, the highest figure for the frequencies. And using the formula, this is L1, which is the lower, class boundary of the modal class, and this is 24.5, just as we have here. Then our F1, this F1 minus F0. So our F1 is the frequency of the modal class, which is 5. Then our F0 is the frequency just before the modal class, that is 3. This is 3 here. Then we have, now here, the denominator, don't forget that it is 2F1 minus F0, then minus F2. So our 2F1 is the frequency of the modal class, which we have done one. Then you multiply it by 2, that is 2 times 5. That's how we have 10. Then our F0 is the frequency just before the modal class, that is 3. Then the frequency just after the modal class, that one too is also 3, as we have here. So then our class width is 4, that is 28.8 minus 24.5. So we have 4. That's how we have this 4. Then conducting mathematical analysis on it, then we arrive at 26.5 to be our mode, to be the mode. Now, relationship between mean, median, and mode. Now, when we have distribution that has uniform number of high and low scores, then the distribution is said to be normal. That is, the numbers are said to be normally distributed. Now, this means that the population mean, population median, and the population mode are all located at the center. Now, this can be represented symmetrically, just as we have here. Symmetrically, like what we have here. Now, by a bell-shaped curve, in which the curve can be divided into 2 equal halves. So, one half is the mirror of the other one. That is, all we have from the left in the left-hand side is equally replicated on the right-hand side. Now, but if the distribution is such a way that the curve is negatively skewed to the left, just like what we have on the board, it means that the mean is the lowest, while the mode is the highest. And this implies that the set of observation has larger number of relatively large scores where mode is relatively high. Now, in this case, it follows the order that the mode will be greater than the median, and the median will be greater than the mean. However, if the distribution has larger number of relatively low scores, then the mean has the highest value, while the mode has the lowest, the least value. So in such situation, it is positively skewed to the right hand side, and this means that the mean is greater than the median, and the median is greater than the mode. With this, we have come to the end of study section 4, the measures of central tendency. And we have specifically dealt with mode. And by now, I believe that you should be able to calculate mode efficiently. And you should be able to explain the relationship between mean, median, and mode. I enjoy you to go over the video clip again to have better understanding of what is contained in it. Thanks for listening.